How many times have you, as a researcher, had to use multiple data loggers and sensors, spending an exponential amount of money on equipment? Today, I'm going to present you hardware developed by us, multiple channels, low cost, and dual data storage data logger for building a soil temperature network published by us, me and Ignacio Stampede, on Hardware X in 2024. In that work, we developed a hardware system that was a network of data loggers to measure temperature in pots with soil. Keep in mind that the use of this hardware is not only limited to soil temperature and can be easily adapted to other targets. You may be asking yourself what the advantages are over a commercial version, and I will point them out. First, it is open source, meaning that you can modify it as you want, suiting it for your applications. Second, as the title informs, our hardware has multiple channels. Let me explain. Suppose that in one of your blocks you need 24 sensors. In the commercial versions, you will need many devices and at a considerable price each to fulfill those 24. But with our hardware, a single data logger and at a reduced cost can support those or even more 24 sensors. But you don't have only one block in your experiment, right? That's why you need a network. The data loggers measure the temperature and send the data to the central through LoRa, allowing long-distance connections. In the central, the data is saved to a microSD card and sent to a remote database, which in this study was a MongoDB cluster. To coordinate data post, get, and data handling, we also set an API in Lightsail. To visualize the results, we built a dashboard using a Shiny app with two data fetching options: local data from the microSD card or remote data from the cluster. Researchers within a limited budget or needing several temperature sensors within each block can take advantage of our hardware in their work. In addition, by being open source, they can modify it to use different sensors rather than only temperature, or even include more than one type of sensor. Of course, our hardware has some limitations, such as we did not test under field conditions, only in a growth chamber, so it is powered from the source. And also, you must coordinate the sampling interval with the number of sensors so as not to overlap reading and writing. Future steps should focus on testing and deploying the hardware, powering it through batteries with optimized power consumption, or renewable sources such as solar, wind, or a mix, and also developing a weatherproof case for it. A simple yet powerful and scalable hardware solution. Check the comments below for a direct link to the full open access paper, schematic files, and source code. Let me know what you think.